Okay, continuing with the review, we're looking at question Z here. We can graph this. You might recognize that this is a line. So you can graph it by plotting points. The easy point is the y-intercept. When x is 0, y is 5. When x is 1, let's see, y is negative 2 plus 5, which is 3. When x is 2, y is negative 4 plus 5, which is 1. So we have a line that has a y-intercept of 5 and a slope of negative 2, which you can see by plotting the point 1, 3 and the points 2, 1. You can see that slope of negative 2. So this line just looks like this. Okay, we would say that this line is always decreasing, so it is decreasing from negative infinity to positive infinity. This is neither even or odd. What else do we need to say? That's it. Okay. All right, so now looking at AA, we want to talk about the domain. Just imagine vertical lines. The first x value that you hit would be negative 2, and you would continue smoothly until you got to 4. So the domain is negative 2 to 4. The range is the lowest y value. Imagine horizontal lines. So from negative 1 to 2 is the range. The y-intercept is, or the x-intercept would be where it crosses the x-axis. The y-intercept is where it crosses the y-axis. Notice that this origin is both an x and a y-intercept. So we have an x-intercept at negative 2, and then also at 0. And then you have a y-intercept at 0 as well. Okay, to determine the functions on which the function is increasing or decreasing, I recommend that students put on a number line the x-coordinates of any mins or maxes. So we have a min at negative 1 and we have a max at 2. And then just describe the behavior. From negative infinity to negative 1, the graph is decreasing. Actually, though, this graph actually starts at negative 2, so it's not from negative infinity because it starts at negative 2 to negative 1, it's decreasing. Then between negative 1 and 2, we have an increasing behavior. And then from 2 till when the graph stops at 4, it's decreasing. So we could say that it's decreasing from negative 2 to negative 1, union 2 to 4, and that's an open parenthesis. And it's increasing from negative 1 to 2. Okay? And this function is neither even nor odd. And that's because if you look at f at negative x, that is not equal to f of x, which if it were equal, that would make it even, and it's not equal to the opposite of f of x, which would make it odd. So this function is neither even nor odd. Okay, on B, what we want to do is figure out what this piecewise function, what kind of behavior we have going here. So what you're going to do is you're going to say, all right, first you test for when g is negative 3, which of these two equations will we go into? We'll go into the second equation because that second equation is what we would use when we have an x value less than or equal to 1, and negative 3 is less than or equal to 1. So g of negative 3 is going to equal negative 3 plus 2, or negative 1. Now g of 1, you'll use the same equation because this equation holds for when x is less than or equal to 1. So it's going to be 1 plus 2, which is 3. But now at g of 3, you're going to use the first equation because that's for x is greater than 1. So that's going to be 2 times 3 plus 4, which is 10. Okay, now you're asked to sketch a graph of g of x and then find the domain and range of g. All right, so we want to sketch a graph. Let's get a little bit of room here. Let's see if I can get it to give me a little bit of room. We have some points already that we can plot. We know the interesting thing, the graph changes at 1. So when x is 1, or when x is 1, g is 3. And then if you pick a number to the left of 1, like 0, you're still going to use this equation. So 0 plus 2 will be 2. So we have a y-intercept of 2. So we just have this line here going down like this for x values less than 1. Now when x is greater than 1, you're going to use this graph. And it's going to kind of start, you can't really plug 1 in, but you can put an open circle where 1 is, and then follow the shape of that graph for x's to the right of 1. So we would have an open circle at 6. And then if you pick a value bigger than 1, like 2, you're going to get, when x is 2, you get, let's see, 8. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Again. And so then the graph looks this way. So our domain is actually from negative infinity to positive infinity. It's defined for all values in the domain. Our range is kind of interesting though, because we jump. We have a value of 3, and then we go from negative infinity to 3, including 3, but then we have an open circle at 6. So we'll have an open parenthesis at 6 and then go to positive infinity. And then we never take on any of the values between 3 and 6, including 6. So these piecewise functions are kind of strange. Okay, so now on this next one, you're asked to graph this function f of x equals negative x squared if x is greater than or equal to 1, absolute value of x between negative 2 and 1, and 2x if x is less than negative 2. So let's think about what that graph looks like. All right, you might want to just pick some points. For values greater than 1, for example, let's go ahead and put 1 in. When x is 1, we get negative 1. If x were 2, you would get negative 4. If x were 3, you would get negative 9, and so on. So you have this part of the parabola like that, negative x squared. Now, between negative 2 and 1, not including 1, you have the v, or the absolute value function. Now, when you if you were to plug 1 in, this is where your open circle will be, you would get 1. So we have an open circle at 1, 1. And now if we plug negative 2 in, we would get positive 2. And those are the endpoints of the v, the part of the v that we're going to use. So you do it like that. All right, and then now we're going to have the graph 2x for x is less than negative 2. So if you put negative 2 in, you'll have an open circle at negative 4. And you could just try some points less. Like, how about if you put negative 3 in, you would have negative 6. So that would be that. And that's just that line. So it's kind of an interesting looking graph. A piecewise defined function is defined in 3 parts. Okay, let's look at the next problem. Now, what we're asked to do on these problems is just describe the transformation from 1 over x. So whenever you have a plus within the operation, or a minus, that's going to, where the operation here is 1 divided by x, this is going to shift it, a horizontal shift in the opposite direction that you think. Plus 2 actually gives a shift left 2. So we have a horizontal shift left 2 units. And this one will give you a horizontal shift right, because of the minus, 3 units. The vertical shifts look right. When there's minus, it's down, and when it's plus, it's up. But the horizontal shifts don't do that. All right, this problem has a lot of different things going into it. What you might want to do is rewrite this one as 2 onto the cube root of, I'm going to factor the negative out, and then I'm going to say that would be x minus 1 and then plus 4. And you can kind of convince yourself that that's the same thing. So then on A, what is it that we're looking at? Well, a negative, let's see, this is a cubic function. This, the minus 1 is going to shift it left 1, I'm sorry, right 1 unit, so we have a shift right 1 unit. The negative is going to be a reflection across the, in this case, that will be the y-axis. It's going to be a y-axis reflection. The 2 on the outside is going to be a vertical stretch up to and then finally, so a vertical stretch, a vertical stretch by a factor of 2, not up to. And then up 4 units. Vertical shift up 4 units. Okay, on B, we are going to, the minus means we're going to go right 1 unit. The minus 1. The negative on the outside of the operation is going to be a reflection across the x-axis. And then the plus 3 is going to be a shift up 3 units. You always do your shifts up and down as the last thing that you say. Okay. Let's see what the next one is. Okay, now we want to graph these functions based on transformations. So this, your parent function, I'll do in blue, would be just y equals x squared, which goes through 0, 0, and 1, 1, also negative 1, 1, and then 2, 4, and negative 2, 4. That would be your original function in blue. That's just your y equals x squared. And then I'll do f of x in red. What happens is each of the y coordinates is going to be moved up 3 units. So instead of 0, 0, you're going to have 0, 3. Instead of 1, 1, you're going to have 1, 4, and negative 1, 4. And instead of 2, 7, you're going to have 2, 8. I mean, let's see, 2 squared is 4. You'll have 2, 7 instead of just 2, 4. So that is the graph of that function. Okay. All right, on FF, let's look at this one. This is the absolute value function. It's shifted left 3. It's reflected across the x-axis and then shifted up 1 unit. So if I do the original absolute value function, it is at 0, 0, and then also at 1, 1, and then at 2, 2. That's your original absolute value function. And then this function, this new transformation, is quite a few transformations. You're going to take each x-coordinate, shift it left 3 units, and then you're going to reflect it across the x-axis, which is not going, that's not going to be a transformation much here on this 0 one. And then you're going to shift it up 1 unit. So we move it left 3, we reflect it, and up 1. So this coordinate, let's take this negative 1, 1, is going to be moved left 3, and then it's going to reflect across the x-axis, so it's going to be down here, and then it's going to move up 1. So it's going to be like that. And then you could choose this point, 1, 1. It's going to go left 3, reflect across, and then go up 1. So there's the new graph. Another way to do that would be to plot points. Notice, like if you choose x to be 1, 2, 3, negative 3, your y value will in fact be 1. If you choose x to be negative 2, your y value will be 0, because negative 2 plus 3 is 1, and then you make it opposite, and then you take it and you add 1 to it, which is 0. So there's kind of more than 1, 2, 3, 4. Same for negative 4, you're going to get 0. So that's another way to kind of see what the new graph looks like. Okay, now On this problem, I want you to actually sketch a graph given this graph. And so what I recommend students do on this is go ahead and take the points that you have. Like you have the points for F, you have the point -4, -2. And you have the point 1, 2, and you have the point 3, -1, and you have the point 5, 4. Just taking those off the graph. And let's do the transformation. The transformation is that you're going to go left 1, you're going to multiply your y by 2, and then you're going to reflect it across the y-axis, so you're going to make it negative. And then the y is going to, you're going to add 3 to the y. So that means you're going to subtract 1 from the x, whatever the x is here. So it's going to be x minus 1, and then the y is going to be -2 times the y value plus 3. Those are your new points. So our new transformed points for g of x are going to be, let's see, -5 because we went less 1, and then this is going to be 7 because it's -2 times -2, which is 4, plus 3 is 7. So our new transformation for 1, 1 is going to be 0, comma, -4 plus 3, which is -1. 3, -1 is going to become, 3, -1 will become 2, comma, and then that's going to be 5. And then 5, 4 will become 4 because we just go down 1 in the x, left 1 in the x, and then the 4 is going to be -8 plus 3, which is also 5, or actually -5. Okay. All right, and so your new points you can plot, if you wanted to, you could plot them on the same graph. So we have -5, 7. I have to go up here. So -5, 7. There's that point. And then 1, 2 becomes 0, -1. So 0, -1. And then 2, 5. And then 4, -5. And so our graph looks like this. This is our new graph, which is stretched, or it's shifted and flipped, or stretched and flipped, and then shifted up 3 units. So that's our new graph. Okay. Okay, now on this problem, you have to do quite a bit of work. We want to write a formula for the piecewise defined function. Well, it's defined, we've got different lines here, so we're going to have to do some work to get the equation of this line. It's easy to find the slope. This is the slope. This line, we were going to go up 3 over 1, so this is the slope of 1 for this line. This slope is up 1 over 2, so this one has a slope of 1/2. And this line is up 1, 2, 3 over 3, so it has a slope of 1. Right? Okay, and so these two, because you know the y-intercept, they're actually easy to say their equations. This is the equation 1x plus 1, because that's a y-intercept at 1. And this is the equation 1/2 x plus 1. So we know 1/2 x plus 1. And this one we're going to have to find the y-intercept. So we know it goes through the point -2, 0. So this is y minus 0 equals 1 onto x minus -2. And so y is equal to x plus 2 will be, see, that doesn't quite look right. Let me see. I'm sorry, our slope on this one is not 1. Our slope is 3 because we go up 3 over 1. Sorry. Okay, so this is a 3. So how about 3x plus 6? That feels better. if you continued this on, you would see that it would cross at about 6. If that makes sense. Okay, so this is the line y equals 3x plus 6. Okay, so the piecewise defined function, the formula for the piecewise defined function, this is part A, for f of x is equal to, all right, from -3 to -2, for x is from -3 to -2, we had that 3x plus 6. Between -2 and 0, we have this line 1/2 x plus 1. And then and on one of these you want to not include, so we can choose not to include on this one. It doesn't really matter. It's not going to be wrong if you not include, because they meet up at exactly the same points. And this one was 1x plus 1 between 0 and 3. So it's less than or equal to 3. Okay, so the domain of this function is clearly just from the lowest x, which is -3, to the highest x, which is 3. Your range is the lowest y to the highest y, which is -3 to 4. We have an x-intercept. It crosses the x-axis at -2, and we have a y-intercept at 1. Okay, and then for each of these, you just want to reflect this graph across the y-axis. This is a reflect. I'm not going to draw each of these graphs, but I'll just tell you it's reflect across y. This is going to be a reflection across the x-axis. This one is going to have a vertical shift up 1 unit. And then this one's going to have a horizontal shift left 1 unit. And then this is a vertical stretch by 2. Okay, and so these, and you could just graph each of those points and do that if you wanted to. Okay, that's it.